Tanner Tech. Hello, this is Tanner Tech, and today I'm going to be showing you how you can build your very own Geiger counter. Now, Geiger counter is a type of electronic device that can detect radiation. So, before I get started, I'm going to go over the circuit diagram with you to explain how a Geiger counter works and how my schematic works. And then, we'll get started building it. So to start, I'm going to explain to you how a Geiger counter works. So pretty much what a Geiger counter is it's an evacuated tube full of an inert gas, such as neon, helium, or argon. And inside this evacuated tube, which is at a very low pressure with this gas, it has two electrodes. One of them is shaped like a little barrel, but in the schematic it's shaped like a horseshoe. And inside it there's a thin little wire. Now this part is the anode, and this part is the cathode. So what happens is when you charge this end to a potential of maybe 400 volts, and this end to ground, then what will happen is nothing will conduct, because this is an inert gas, and this is not a high enough voltage that will break down the gas. But what happens is if there's a radiation source nearby, such as americium or plutonium or whatever radiation source you have, it'll emit particles. So what happens is when these radioactive particles fly through and hit the gas, they will ionize the inert gas in between here, which will cause a momentary current flow between these two electrodes. And if we have a current meter on here that can measure in the quantity of microamps, then this will tell us if there's radiation. And depending on how many radiation particles hit this little horseshoe apparatus, it'll tell us how much radiation is in the air, which is the purpose of this experiment. So let's get to the actual circuit diagram. So over here we have a 555 timer, and with the combination of these resistors and these capacitors, it generates a certain frequency square wave. This square wave goes through a resistor to drive a MOSFET. This MOSFET drives this transformer right here. This transformer steps up the voltage from 9 volts, which is the supply voltage, to a voltage of about 300 volts. This voltage is then doubled through this voltage doubler and to a very high voltage. Then it is regulated by these 4100 volt Zener diodes, so it is a 400 volt power supply. Now this 400 volts is applied to the anode of the Geiger tube, and on the cathode, between the cathode and ground, I have a piezo element. So what happens is there's a high voltage here, and whenever an ion from radiation hits this Geiger tube, then it'll cause current to flow through here and flow through the piezo element. And because it's a high voltage, it will not hurt the piezo element, and it will cause an audible click that you can hear, which will tell you there's radiation. So this right here is the Geiger counter that I built. So right here is the Geiger tube. I got this tube from Russia, and it's kind of funny because when I got it wrapped in a Russian newspaper. And here is the piezo element, and then here are the 4 regulating Zener diodes, multiplier, and the transformer. So this is all the components. I have it on a piece of perf board, and I have it all soldered together on the bottom. So this right here is my Geiger counter. So if you want to build this Geiger counter, just beware of the high voltages, and when you build it, just follow the circuit diagram, and it should work. So let's test this thing. So after obtaining your 9 volt power supply, in this case I'm using my bench power supply, you can connect it to your Geiger counter via alligator clips, and we can fire it up. Now when you turn on this Geiger counter, you should hear a high-pitched noise. This is just the sound of the transformer oscillating. So then I'm going to take a radiation source and place it in front of here, and you'll be able to hear it. Now to do this, I'm going to carefully remove my radiation source with pliers. Now this radiation source is americium from a smoke detector. Now as you can see, or hear, as soon as I put my radiation source right next to the Geiger tube, you can hear it clicking. So as you can hear, this thing works perfectly, and I hope you could hear those clicks on the piezo buzzer, but this Geiger counter works very well. This counter consumes very little milliamps, so it should be able to run fine on a 9-volt battery for portable use. As always, thank you for watching, and please subscribe.